Dear students, welcome to today's class. So in the last class, I have explained about empty relation or void relation, universal relation, identity relation, reflexive relation, symmetric relation, antisymmetric relation, transitive relation, equivalence relation. Okay now, so we have seen the definitions of those types of relations. Now we are going to solve some problems based on those types of relations. Okay, so coming to the first problem. So welcome to first problem. The relation R on the set of natural numbers n is defined as x is related y. X or y means x is related to y. How it is related? Such that x square minus 4xy plus 3y square is equal to 0, where x and y are natural number, then R is A. Now the options are known options only. So we have to check R is a reflexive or symmetric or transitive and equivalence relation. So I am not writing the options here, but almost for all problems. So this type of relations will be given, and for that relation we have to check whether they are reflexive or symmetric, transitive, antisymmetric, all those things. Okay now, right, check. First of all, check whether it is a reflexive or not. To check the reflexive, what I told, so here what is the basic domain of the relation? N, set of natural number. So to check the relation is a reflexive or not, first relation is reflexive relation. To check the reflexive relation, let us take one natural number, only one natural number. X belongs to n natural number. Okay, now apply the condition x related to x. How is it related? X square minus 4xx plus 3x square. What is the value of this? X square plus 3x square, 4x square. 4 into x, 4x square. 4x square minus 4x square is equal to 0. Right or wrong? Yes, it is right. So x is related to x. Under this condition is always true. Therefore, R is a reflexive relation. Okay. Let us check for second one. Symmetric. To check the relation is symmetric, you have to take any two natural numbers. Okay now, any two natural numbers. Let us take the natural numbers as x and y belongs to R. Now, what is a symmetric relation? If A comma B belongs to R, then B comma A also should belongs to R. Then only the relation R is called symmetric relation. That means if A comma B, how is A is related to B, the same relation should be maintained to B, from to B to A also. Understand? If A loves B, then B also should love A. Okay now? So this is then we call it as a symmetric relation. Okay. First of all, let us take the two elements which are natural numbers n. Therefore, apply the relation x or y. X or y. So this implies x square minus 4xy plus 3xy. So this is a condition given 0. It is given. Now the same thing is y or x value. Y is related to x value is also 0. Let us check. Now it is given as a y square minus 4yx plus 3x square. Is it also equal to 0? Definitely not. It is not equal to 0. Okay now, if you see that any numbers, if you substitute any numbers, definitely it is not equal to 0. Definitely it cannot be equal to 0. Therefore, R is not symmetric relation. Okay. So let us check this transitive relation. Let us check further. So to check the transitivity of a relation, we have to take three numbers. Here discussion of the domain is numbers. That's why you have to take the three numbers. Let us take the three numbers x, y, z belongs to natural numbers. Okay now. Now to check this transitivity, so we have to see the definition as if x is related to y and y is related to z, then x should be related to z. Then only we say that this relation is a transitive relation. Okay na? So let us check the transitivity of this relation. Dear students, let us check the transitivity of this relation. For example, 9 is related to 3. Is it right? Is it right? Check it. Check it. That is 9 square, 4 into 9 into 3 plus 3 into 3 square. So 9 square is equal to 81 minus 4 into 9 into 3. So 4 9s are 36, 3s are 3 6 are 18, 3 3s are 108 plus 3 square 9, 9 3s are 27. So if 81 plus 27 is 108, 108 minus 108 is 0. Therefore, 9 comma 3 belongs to the set of natural numbers n cross n. Let us check 3 or 1, that is 3 square minus 4 into 3 into 1 plus 3 into 1 square. 3 square 9, 4 3s are 12 plus 3. This is also 0. That means 9 comma 3 belongs to R. 9 comma 3 belongs to R. 3 R1 means what? 3 comma 1 belongs to R. If it is a transitivity, if the relation R is a transitive, then what must be belongs to R? 9 comma 1 must be belongs to R. If it is belongs to R, then we say that it is a transitive, R is a transitive relation. Of course, if it is not belongs to, then it is not a transitive relation. Let us check that. So 9 related to 1. How? According to the definition, this is equal to 9 square, 4 into 9 into 1 plus 3 into 1 square. 9 square 81, 4 9s are 36 plus 3 is equal to 0. No, it is not at all 0. That means A comma B belongs to R and B comma C belongs to R. Both are in the set of natural numbers n cross n. But A comma C, does not belongs to R. Therefore, R is not transitive. It is not transitive. So from this we can say what the relation, the defined relation is reflexive, symmetric, but it is not transitive. Okay, now I hope that you understand this solution. Let us go for next problem. Dear students, welcome to second problem. A relation or on the set of non-zero complex numbers. It is a non-zero complex numbers is defined by Z1 related to Z2. Here Z1, Z2 are non-zero complex numbers. They are not zero complex numbers, non-zero complex numbers. How it is defined? Z1 minus Z2 upon Z1 plus Z2 is a relation. So these two complex numbers Z1 and Z2, they are related. How they are related? Z1 minus Z2 upon Z1 plus Z2 is a real number. Then the R is. So options are clear. Reflexive, symmetric, transitive, reflexive but not symmetric, symmetric but not transitive, transitive but not reflexive. Like that the options will be there. Okay, there is options are well known. Now let us check the reflexive relation. Reflexive relation. So here to check the reflexive relation, what I told, take one number, one line, one triangle, whatever may be that, you take only one item. So here what are the discussion of the domain? Complex numbers. So let us take a complex number. Let Z1 belongs to a complex number C and Z1 is not equal to 0. Non-zero complex number. So Z1 is a non-zero complex. Let us take now. Now apply the relation Z1 related to Z1. See here Z1 related to Z2. Who is Z1 minus Z2? So here what I have write down? Z1 minus Z1 by Z1 plus Z1. That is 0 by 2 Z1. Obviously it is a 0. 0 is a real number. Right or wrong? Yes, clear. 0 is a real number. Therefore, the relation R is a reflexive relation. Okay, now let us check that symmetric relation. Symmetric relation. To check the symmetric relation, what I told, take any two things, two distinct numbers, two distinct lines, two distinct triangles, whatever may be the two items you take. So let Z1 and Z2 belongs to set of complex numbers. Obviously Z1 and Z2 they are non-zero. First apply this condition. So that is what? Z1 related to Z2. This is equal to Z1 minus Z2 by Z1 plus Z2 is a real number. Is a real number. It is given. It is a real number. Then we have to show that Z2 is related to Z1. Z1 is related to Z2, same as Z2 is related to Z1. Now for this I am saying that, so let us take minus common outside. Z2 minus Z1 by Z1 plus Z2 is a real number. Is it true or wrong? Am I wrong anything writing? Why? Because for example 5 is a real number, minus 5 is also a real number. Yes, I multiplied with minus 1, then minus 5 is also a real number. Yes. So minus of Z2 minus Z1 is also a real number. Of course, I interchanged this Z2 minus Z. Now one more thing, if I is a real number, if I multiplied with the minus 1, then it is also a real number. You multiply with the minus 1, so this is a Z2 minus Z1 by Z1 plus Z2 is a real number. Is it not Z2 related to Z1? Z2 is related to Z1? Yes, it is. That means if Z1 is, how Z1 is related with Z2, same relation, Z2 is relation with related to Z1. Okay na? So this is a symmetric relation. Okay na? So let us check for transitive relation. Let us check the transitivity of this relation. Okay, so we are checking transitivity. Transitive relation we are checking. So to check transitive relation, what I told, you have to take any 3 items, that is either 3 numbers or 3 triangles or 3 lines, whatever may be the 3 distinct numbers you have to take. So here what is the numbers here? Complex numbers, that Z1, Z2, Z3 belongs to set of complex numbers. So in order to check this transitivity of relation, so let us take a Z1 is equal to A1 plus B1I, Z2 is equal to A2 plus B2I, Z3 is equal to A3 plus B3I, where A1, A2, A3, where A1, A2, A3, B1, B2, B3, they all belongs to real numbers. Okay now. So Z1, Z2, Z3, I have taken 3 complex numbers, of course non-zero complex numbers. First I will take this. What is that? Z1 related to Z2. Z1 related to Z2. Now according to the definition, what is that? Z1 minus Z2. That means A1 plus B1I minus A2 plus B2I divided by Z1 plus Z2. That is A1 plus B1I plus A2 plus B2I. This is given by 0. That is equal to, is a real number. Z1 or Z2 is equal to 0. Let us take sorry, it is not given. So let us take this. So to in order to simplify this, let us take this as a A1. First of all, you simplify this. So this is nothing but A1 minus A2 plus I times B1 minus B2. So here also A1 plus A2 plus I times B1 plus B2. Okay now, understand this. So it is already given that it is a real number. He is saying that is a real number. He is saying is a real number. So for my convenience sake, I will take this real number as a 0. This real number is a 0. So if you cross multiply, this will become a 0, and after simplification, A1 minus A2 is equal to 0 and B1 minus B2 is equal to 0. That means A1 is equal to A2, B1 is equal to B2. So from this we can say that A1 by A2 is equal to B1 by B2. Call it as 1. A1 by A2 is equal to B1. So here he is saying that is a real number. For my convenience, I am taking 0 as a real number. Right. Let us take this. Z2 related to Z3. So if I have taken Z1 related to Z2, what have taken? What have I got? A1 by A2 is equal to B1 by B2. Right. If you simplify the same manner, it is same logical apply. If you proceed like this only, then what you will get? B1 by B2 is equal to C1 by C2. Call it as 1. Now see this from 1 and 2. So A1 by A2 is equal to B1 by B2. There we got B1 by B2 is equal to C1 by C2. Here A1, B1, C1, A2, B2, what are they? They are real numbers. So real numbers satisfy transitivity. That means if A, B, C, if A is equal to B and B is equal to C, automatically A is equal to C. Real number, set of real numbers satisfies transitive property. Therefore, here A1 by A2 is equal to C1 by C2. That means what? Z1 related to Z2 and Z2 related to Z2. From this what you can conclude? Z1 is related to Z3. Z1 is related to Z3. Okay now? So that means what? A comma B belongs to R, B comma C belongs to R, then A comma C also belongs to R. Then we can say that this R is a transitive relation. Okay now? So this is from this we got that, so it is a reflexive relation, and it is a symmetric relation, and it is also a transitive relation. Therefore, we can conclude that it is an equivalence relation. Okay now? Right, I hope that you understand this solution. Let us go for next problem. Dear students, welcome to third problem. This was asked in 2008 AIEEE. That means, so this was an exam conducted before JEE mains examination. Okay now? So, see the problem. Let R be the real line. So, real number line. Consider the subsets of the plane R cross R. In R cross R, how many ordered pairs will be there? Infinite number of ordered pairs will be there. From that infinite number of ordered pairs, he has selected some ordered pairs x comma y such that y is equal to x plus 1. And that x is also belongs to 0 to 2. The number x also belongs to 0 to 2. X is a number belongs to 0 to 2, so that according to that y also will depend. Okay now. So let us see that and the second set is given x comma y such that x minus y is an integer. Then which of the following is true? So here are the options are S is equivalence relation, T is equivalence relation. Both are equivalence relation. Both are not equivalence relation. S is equivalence relation, T is not equivalence relation. T is equivalence relation and S is not equivalence relation. On the whole, we have to check whether S is an equivalence relation or not, T is also equivalence relation or not. So to check that is a equivalence relation or not, we have to check the three relations. What is that? Reflexive, symmetric, transitive. Okay now? So let us take the first relation, S. So S is given as x comma y such that y is equal to x plus 1. And it is given 0 less than x less than 2. So to check this reflexive, to check it is a reflexive, what have taken? We have to take any one number. So on the real number line, let us take only one number. That means x comma x belongs to R cross R. Now you check it is if x comma y belong such that y is equal to x plus 1. No. Now here what is that? X is equal to x plus 1. Check. What you will get? So almost x will get cancelled. 0 is equal to 1 we are getting. Is 0 is equal to 1 is a true? No, it is not at all a true. Therefore, R is not a reflexive relation in here. Therefore, the set of ordered pairs which belongs to S, they does not satisfy the reflexive property. So, no need to check symmetric and no need to check transitivity. On the whole, S is not an equivalence relation. Okay now? Right. Now, let us check for T. Okay now. Clearly, if x comma x is there, x minus x which is an integer. So, reflexive is satisfied. Now, coming to symmetric. If x comma y, that means if x minus y is an integer, then y minus x is also integer. That's all. For example, minus 3 is an integer, 5 is integer, minus 5 is also an integer. Its negativity is also an integer. That's very clear. Symmetric is over. Now coming to transitivity. Let us take x comma y belongs to the relation. Therefore, x minus y belongs to integer. Let us check y comma z belongs to R. This implies y minus z is an integer. So both are integers. X minus y is an integer, y minus z is also integer. Therefore, the difference of two integers is also an integer. For example, otherwise their sum is also an integer. For 2 is an integer, 3 is integer, 2 plus 3 is also an integer. Therefore, x minus y plus y minus z also belongs to, or plus y minus y will cancel, x minus z, that is x is related to z, is also related. So clearly the set T is an equivalence relation. Why? It satisfies reflexive, symmetric, transitive, whereas the first set does not satisfy reflexive. Therefore, your answer is T is equivalence relation, S is not equivalence relation. So that is the answer for this problem. Okay, I hope that you understand this solution. Let us go for next problem. Dear students, welcome to fourth problem. Consider the following relations. Here too there are two relations is given. The first relation is x comma y such that x and y are both real numbers, such that x is equal to wy, where some y is a rational number, some rational number. Okay, now that means there are two numbers are there such that x is equal to wy, where w is a rational number. Like that, another set is also given. In that set, there is an ordered pair m by n comma p by q. M and p q are integers such that here denominator n and q, they are not equal to 0. And the condition is here, what is that condition? How he is taken that ordered pairs, first element, second element, how he is taken means, see here, mq is equal to np. Mq is equal to np. So mq is equal to np. Such a type of ordered pairs has taken. For example, 3, 4, 6, 2. Like that ordered pairs he has taken. That means 3 4s are 12, 6 2s are 12. 12 is equal to 12. Like that of type of ordered pairs he has taken. Okay, now, right. That we have to say that whether R is a same, options are same. What are the options means? We have to check whether R is an equivalence relation or not. S is an equivalence relation or not. Or both are equivalence or both are not equivalence relation. Let us check one by one. First one I am taking R. Reflexive. Reflexive means what? You have to take any one number, one line, one triangle, any one item you have to take. Let us take that x belongs to real numbers. Therefore, x comma x belongs to R, such that x is equal to wx. Is it right? Is this statement is right? Yes. What is w? W is a rational number. You can take x is equal to 1 into x, no? X is equal to 1 into x. 1 is a rational number. Yes. R is reflexive relation. Let us check symmetric relation. Symmetric relation means what? X comma y belongs to R. That means x comma y belongs to means R means what? X is equal to w into y. Understand? Is it right that y comma x is also belongs to R? Is belongs to R. That means is y is equal to x, is y is equal to w into x. Same rational number can you get? Can you get the same rational number? The rational number should be same. Can you get the same rational number? No, you cannot get. For example, 12 is equal to, so 12 is equal to 2 into 6. 12 is equal to 2 into 6, where 2 is a rational number. Is it 6 is equal to 2 into 12? No, fail. Therefore, this is not a symmetric relation. Okay, now, right. So, therefore, it is not equivalence relation. R is not an equivalence relation. Why? It is failed for symmetric relation. Okay, now let us check S is a equivalence relation or not. So, first we will check for reflexive, symmetric, transitive. Okay, now let us check S is an equivalence relation or not. So, first one is reflexive. Reflexive relation. That means what? For example, m by n, one number. Here, see here m by n, p by q, both are fractions. We have to take one fraction to check the reflexive, one fraction. Let us take the fraction m by n, m upon n, related m by n. Is it right? Is it right? Check it. M into q is equal to p into n. That is m into n is equal to m into n. Right or wrong? Yes, right. M into N is equal to M into N, right? So, S is a reflexive relation. Let us check for symmetric relation. Symmetric relation means what? You have to take the two items anything. Two fractions, that is M by N is related to some P by Q according to the definition. So, MQ is equal to Pn. MQ is equal to Pn. Okay, na? Right. Let us check it is right also not. MQ is related to Mn. M by PQ is related to M by N. Let us check according to the definition M into Q. Here P into N is equal to M into Q. Both are same it or not? Both are same. So, we have MQ is equal to Pn. From this we got Pn is equal to MQ. Both are same or not? Yes, both are same. Therefore, clearly S is a symmetric relation. Okay, na? So, let us check for transitivity. To check the transitivity of the set S, we have to take any three fractions. Let us take the fractions M by N, P by Q, R by S belongs to the set S. Here S is a small s. Okay, of course, N, Q, S, they are not equal to 0. First, let us apply the condition for first fraction and second fraction. What is that? So, according to the transitive property definition, I am writing if A comma B belongs to R, B comma C belongs to R, then A comma C also belongs to R. If it is there, then it is a transitivity. Otherwise, it is not transitivity. Okay, now? Right. So, first here A, B, C, A comma B belongs to R. What is the condition here? M into Q. M into Q is equal to P into N. Okay, now? Now, B comma C belongs to R. Now, what is that condition? P into S is equal to Q into R. P into S is equal to Q into R, right? These two things we have. Then what we have to check? We have to check that A comma C belongs to R or not. Okay, now that means what? M by N comma R by S belongs to S or not. That means what the condition we have to prove? M by N, R by S. That is MS is equal to NR. That we have to prove. If we prove that MS from these two conditions, if you are able to prove that MS is equal to NR, MS is equal to NR, the problem is over. That means what here? We have to remove P and Q. So, from this you see here, P by Q is equal to R by S. P by Q is equal to R by S, right or not? In place of here, M by N is equal to P by Q. From this, can I say that M by N is equal to P by Q? In place of P by Q, I wrote M by N. M by N is equal to R by S. From this, is it not MS is equal to NR? Got it or not? We got MS is equal to NR. MS is equal to NR means what? M by N comma R by S belongs to S. Understand this? Okay, na? Right. That means what? A comma B belongs to S, B comma C belongs to S. Automatically, A comma C is also belongs to S. Then we can say that the set S satisfies transitive property. So, it is already reflexive, symmetric and transitive. Therefore, S is an equivalence relation, whereas R is not equivalence relation. So, it satisfies a reflexive property, but it is not satisfying symmetric property. Okay, na? So, I hope that you understand this solution. So, let us go for next problem. Dear students, welcome to fifth problem. R is equal to a relation is given, that is 1 comma 3, 4 comma 2, 2 comma 4, 2 comma 3, 3 comma 1. Be a relation on the set A. That means what? R is a subset or equal to A cross A. That means from this A cross A, 4 4s are 16 ordered pairs will be there. 16 ordered pairs. You know that 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, like that. 16 ordered pairs will be there. From that 16 ordered pairs, he has taken some ordered pairs. What are that? 1 comma 3, 4 comma 2, 2 comma 4, 2 comma 3, 3 comma 1. Okay, then we have to see that then R is A. Here the options are R is reflexive but not symmetric but not transitive. Second option is R is symmetric but not reflexive but not transitive, like that. Option C is R is reflexive, symmetric, transitive. Option D is neither reflexive, neither symmetric, not transitive. Those are the 4 options we have. Okay, na? So let us check one by one. So first one is reflexive relation. Right. What are the reflexive relation definition? If A comma B belongs to R, then A comma A should belongs to R for all A belongs to capital A. See here, whatever may be the set contains elements 1, 2, 3, 4. For every number, the relation should satisfy. That means what? 1 comma 1 should belongs to R. 2 comma 2 should belongs to R. 3 comma 3 belongs to R. 4 comma 4 should. That is the meaning of this for all A belongs to A. So clearly see here, 1 belongs to A, but 1 comma 1 does not belongs to R. 1 comma 1 does not belongs to R. Therefore, R is not reflexive. Clearly. Second one is symmetric relation. So to check the symmetric relation, so what is the definition of symmetric relation? If A comma B belongs to R, then it should be B comma A also should be belongs to R. If A comma B is there, B comma A also should be there. So if you observe here, 1 comma 3 is there as 3 comma 1 is there as it is okay. Next, 4 comma 2 is there, then 2 comma 4 is also there as it is there. It is there. So next, if you observe here, 2 comma 3 is there, but 3 comma 2 is not there. See here, 2 comma 3 belongs to R. It must be 3 comma 2 is also should be there. If it is 2 comma 3 there, we have to search for 3 comma 2. But 3 comma 2 is not there. Therefore, R is not symmetric. R is not symmetric. Let us check for transitivity. What the transitivity say? If A comma B belongs to R and B comma C belongs to R, that means A comma B is there, B comma C is also there, then it must be A comma C. If it is belongs to R, then it is a transitivity, otherwise it is not a transitivity. Okay. For example, but that means what? First A comma B, B comma C should contain R. If you observe here, 1 comma 3 belongs to R, right? 1 comma 3 belongs to R. Clearly 3 comma 1 also be in R, but 1 comma 1 does not belongs to R. 1 comma 1 does not belongs to R. Therefore, R is also not transitive relation. Understand that. So the given relation is, unfortunately, it is neither reflexive nor symmetric nor transitive. All the 3 relations it is not satisfying. Therefore, it is not at all an equivalence relation. If any one of the conditions is not satisfied, then it is not an equivalence relation. Okay, na? Right. So I hope that you understand this solution. So let us go for next problem. Dear students, welcome to 6th problem. So it is a very nice problem. So it was asked in 2006 AAEE. Let W denote the words in English dictionary. Right. In the English dictionary, you will have so many words starting from A, cat, cat, D was dog, so many words will be there. See the image in the Oxford dictionary. Okay. In that dictionary, in that words, there is a relation defined. How it is relation defined? X comma Y belongs to W cross W, such that how it is? The words X and Y have at least one letter in common. At least one letter in common. That means what? You have to take the words which have at least one letter common. For example, CAT, cat, TOY, toy. This type of words you have to take. By CAT, cat, TOY, toy. So here what is the common? CTT. TT is common. At least one letter. At least one letter is common. CAT, cat, TOY, toy, like that. You should not take like this. CAT, cat, DOG, dog. You should not take this type of words. Why? Because no letter is common. CAT, DOG, all are different. So you should not take this type of words. You have to take the words which have at least one letter. CAT, cat. Maybe 2 or 3 letters also may be equal. Okay. For example, anything 2 letters also may be common, but at least one letter common. Now you have to check this relation is. So options are obviously I already told, reflexive or symmetric or transitive. That's I have options. I am not writing. Right. Check. We have to check whether it is a reflexive, symmetric, transitive. Okay. Now let us start the problem. So first one is reflexive. Reflexive. Reflexive means what? You have to take one word only. It is obviously a reflexive relation. For example, CAT, cat and CAT, cat. CAT, 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 cat. He is saying at least one letter. Here all the 3 letters are common. All the 3 letters are common. CAT, 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 cat. As it belongs to set of the given relation. Yes, it is a reflexive. Second one I will check for symmetric. To check the symmetric, you have to take the 2 letters, 2 words, sorry. Let us take CAT, cat and TOY, toy. It is a belongs to R. SY, how can you say TT? One letter is common. Obviously, TOY, CAT also belongs to right. Why TT? Same or not? TT, yes. It is a symmetric relation. Let us check the transitive relation. Transitive relation. Then to check the transitive relation, I already told, to check the reflexive, you have to take only one item, one word. Here what is the W is that denotes the words. That means one word you have to take. To check the symmetric, 2 words you have to take. To check the transitivity, we have to take the 3 words. Let us take the 3 words as a CAT, cat, TOY, toy, YOU, U. Clearly, CAT, cat, TOY, toy, both belongs to our relation R. Why? T is the common. TOY, toy, YOU, U. Both belongs to our relation Y. Why? Because Y is a common. One word is common. Of course, UO also common. 2 letters are common. But if you observe CAT and YOU, or any one, at least one letter is a common? No. CAT, here YOU, yes, they are not common. That means what? A comma B belongs to R, B comma C belongs to R, but A is not related to C. Obviously, it is not a transitive relation. That means what it fails? It is a reflexive, okay, symmetric, okay, then it fails transitive. This type of logical problems are giving. Okay, now? So I hope that you understand this solution. Dear students, I hope that you enjoyed today's class. In the tomorrow's class, we are switching on to a very important chapter, that is functions. So from functions, at least one question is giving in JEE mains examinations, a very important topic, that is functions. Those who are perfect in sets and relations, the function chapter is very important. Okay, now? So with functions chapter, tomorrow I am going before you. Until then, all the best.